Good morning, ladies and gentlemen. It is time for the last note section of the chapter. And this note section tends to be a little bit tricky for some people, and then other people pick it up right away, kind of depending on how familiar you are and how easy it is for you to picture 3D shapes. So today we're going to talk about the three-dimensional Pythagorean theorem, which is not a new theorem. This is just an extension of how we've been using the Pythagorean theorem already. We're just going to continue using it, kind of extend that knowledge. So we have two shapes that we're going to be focusing on. We'll focus on rectangular prisms, and we'll focus on pyramids down here. And your homework is going to have sort of a mix of both of those things. So first of all, this first one says the dimensions of a box are 3, 5, and 7. So they've put the 3, the 5, and the 7 there. What is the length of the diagonal HB? So oftentimes we might not get the letters here, but what it'll say is what is the length of the diagonal. And if you have a three-dimensional shape and they say what is the length of the diagonal that they're talking about is the diagonal that goes the longest. So from the top back corner, the bottom front corner is going to be the longest diagonal in the shape, and that's what they're looking for. So in order to find this diagonal, we have to actually do a couple of different steps that will result in us doing the Pythagorean theorem 2 separate times. So in order to find this diagonal, we're going to have to think about how to get there. So see, this dotted line sort of makes its own right triangle. If we can use the Pythagorean theorem on that dotted line, then we can find this hypotenuse here. And we know this is 5 because the height of our shape is 5. But we don't know this side yet. However, it's part of another right triangle with side lengths 3 and 7. So if I use the Pythagorean theorem here to find this length, I can use the Pythagorean theorem again to find this length. And that's what I'm going to do. We're going to start with this bottom right triangle here. We can see that it's a right triangle. So we can say that this is 3 squared plus 5 squared equals d squared. I'm going to call it d for diagonal. And that's going to be 9 plus 25 equals d squared. So that is, shouldn't be 3 plus 5. It should be 3 plus 7 squared. And that should be 9 plus 49. I apologize for that. So 9 plus 49 equals d squared. And so that is going to be 58 equals d squared. And to find the diagonal, we'll take the square root of both sides. So the square root of 58 is equal to the diagonal, right? I could write it here if I wanted to. And now I know two sides of the remaining right triangle. Now I know it's 5 and it's the square root of 58. So now I'll say 5 squared plus the square root of 58 squared equals diagonal squared. I'm going to make that a capital D so that I can show that it's the longest or the principal diagonal. So this is going to be 25 plus the square root of 58 squared is 58 equals d squared. And that's going to make 83 when I add those together equals d squared. Take the square root of both sides and I get just the square root of 83 that doesn't simplify equals the diagonal HB. So my longest diagonal here has a square root of 83. Coming down here, we have some other words. So it says the figure at right is a regular square pyramid. Now that's a really important word. We haven't talked about the word regular yet, but it is going to happen sometime soon once we get into our area unit. So a regular square pyramid just means that all of the side lengths of the base here are the same length, which regular and square in this case kind of mean the same thing, right? Regular means all the side lengths of the base are the same length, but we know that because it's a square pyramid, so we already know all the sides of the base are the same length. But this becomes a significant word later. With altitude, PR, so if you think of this as a circus tent, the altitude is right from the middle of the tent to the very top of that roof part. So the altitude is PR, and slant height, PS. So slant height is the height of a face of a pyramid. So the face is this flat triangle. The slant height is the height of that triangle. It says the perimeter of JKMO equals 40. Well, that's the square base, and I know it's a square, so I can say that's 10, 10, 10, and 10. All right, so, and then PK equals 13. So PK is this side right here. It's an edge, so we'll say that's 13. So here it says find JK. Well, we just kind of did that already. We took our perimeter of 40 and we divided by 4. And we said that each of those, including JK, is 10. Then we want to find PS. And PS is this slant height right here. So we need to think of a right triangle that maybe we know two sides of to help us find the third side of this right triangle. And I see that I know that this is 13. I also know that my base is 10. And a slant height on the base is going to come down and it's cut that base right in half. So this side, SK, that's going to be 5. And if I look at this now, I have 5 and 13 is a right triangle that is a right triangle with PS. And I remember that I have a Pythagorean triple, right? Let me draw this triangle over here so you can see what I'm talking about. So this is this triangle right here. So I have 5 and I have 13. I just need that third side. It's Pythagorean triple, so I know that third side is 12. All right, and then finally I have to find PR. So let me write in that I have 12 here for my slant height. PR is the altitude of this shape. So in order to find the altitude, I'm going to think, okay, I need to have the right triangle that incorporates this piece. And I see that the right triangle that incorporates this piece comes across right here. And I know that the hypotenuse of this right triangle is 12. I don't know the base, but now that I think about it, I do know that base because I know the dimension all the way across is 10, and I know that this goes halfway, so that's 5. So I have a new triangle. I can draw it down here, redraw it. It's got a base of 5. It has a slant height, or a hypotenuse, of 12, and we're looking for this side. You can't even see that. Sorry about that. So to find that, I'm going to use the Pythagorean theorem, and I'm going to say x squared plus 5 squared equals 12 squared. So that's going to be x squared plus 25 equals 144. Subtract 25 from both sides. X squared equals 119. And then we'll take the square root. X equals the square root of 119. All right, and that won't simplify. So my altitude, if you think of that circus tent pole going right up through the top, is the square root of 119. That is all the examples that we have for you today because there are really only these two shapes in your homework. So go ahead and look at your homework, see what you can do with that, and if you have any questions, let me know. Have a great day, guys.